Hi everyone, I am Madam Rosmaya. Welcome to my YouTube channel. So in this video, we are going to discuss on tutorial 14. So the topic is teen film. And make sure before you watch this video, you've tried the questions given in the description link below. Uh, the first question. Okay, we read the question together. A ray is at near normal incidence on a thin film as shown. So the refractive indices of the media are as indicated in the figures. Express the total optical path difference between the two reflected rays in terms of the thickness d of the film and the wavelength lambda of light. Okay, so in this question A, we are given N1, 1, N2, 1.3, and 1 again equals to 1. So that's mean the ray is incident to a medium N2 and then coming out to the same medium as the incident ray. Okay, now look at the arrow of the ray. Okay, so we know that from the given effective index, N2 is larger than N1. So the ray reflected on the first, the interface here. So optical path is equals to the half lambda. Okay, for the first ray. Then for the second ray, it travels further through the medium and with refractive index N2, and then reflected at the second interface, then refracted out, and the optical path is equals to 2 nd. Because the thickness is d, the formula of optical path is nd, so it travels 2 times. It travels to and fro here, so that's mean 2 nd. And then the reflected ray here is at the interface here is from a denser to the less dense medium, and one is less than N2, so that's why the optical path is only 2 nd. Okay, so now the difference between these two optical paths is equals to 2 nd minus half lambda, so final minus initial. So these two ray, they superpose here. Okay, and the from the optical path difference between these two is 2 nd minus half lambda. Okay, so this is the answer because the question wants the total optical path difference, okay, between the two reflected rays here. So next we go to question B. Okay, this time in question B, okay, so we forgot to simplify, okay, the just now the question, and we substitute the n given 1.3 into the equation here, the path difference here, and we get 2.6d minus half lambda. So this is the answer, optical path difference in question A. Okay, for question B. For question B, the ray travel through the medium, denser medium here, and then coming out to the to the medium where n different n, which is 1.5, and this one is not n1 actually, n3, okay, typing error, so 1.5. And the ray is reflected in the interface where the medium, the interface here is from the denser medium, 1.5 less denser than 1.3. Okay, so now for N2 is larger than N1. Okay, so it's denser. N2 larger than N1. So the first ray, when it is reflected to the interface where N2 larger than N1, so the optical path is equals to half lambda. Okay, now the second ray, when it's refracted and then reflected again the second interface, and we now N3, this N3 is larger than N2, 1.5 larger than 1.3. So what happened? The optical path become 2 nd plus half lambda. So we must add half lambda because the interface here is between the 1.3 that less dense than the 1.5. So here is the denser medium. So that's why we must plus the half lambda. Okay, so now the optical path difference will be final minus initial, so 2nd plus half lambda minus half lambda. So we get simplify this, so we get 2nd. Then we substitute the n here, the reflected ray is in the medium 1.3, so you substitute 1.3 into the equation and we get the answer 2.6D. Okay, so that's the answer in question 1. Now we go to question 2. Okay, monochromatic light of wavelength 600 nanometer is at near normal incidence on a soap film. So calculate the minimum thickness of the soap film which would produce constructive interference, then destructive interference of the reflected light. So reflective index of the soap film is 1.33. Okay, so the first question. Okay, the soap film, okay, has refractive index N2, and then the ray coming from the air, which is N1, equals to 1, and the N2 is 1.33, and then coming out to the air, okay, the ray coming out to the air, so N1, N2, then followed by N1. So the ray travel, the first it will reflected to the first interface. Okay, the optical path will be half lambda because N2 is larger than N1. It's denser than N1. Then the second ray reflected towards the second interface where N1 is less dense than N2. So therefore, the optical path is just 2nt. So this time we use the thickness of the soap film as T. Okay, given here not given, so we use T this time, and it's stated here near normal incidence, so that's mean near normal incidence, so we assume that the light travel here through the thickness T. Okay, so if it's not near normal, so we need to use the trigonometric ratio, okay, to get the distance travel by in the medium N2, the distance light travel in the N2. But because this is near normal, so we can just assume the optical path is 2nt. Okay, double journey here. Okay, so the path difference between these two will be 2nt minus half lambda. Okay, so now for the first question here, constructive interference. So this optical path difference to get constructive interference is equals to the m lambda. So m is in the order of 0, 1, 2, 3, and so on. But because the questions want the minimum thickness, so we substitute the minimum order, which is m equals to 0. So when m 0, and we substitute the n value, okay, the n this n is n2, okay, the thin film, and minus half lambda. Lambda is given 600 nanometer. Okay, so we get we solve this, we get thickness of the thin film is 1.13 times 10 to the power of -7 meter. Okay, so now we go to question B. This times we want the reflected reflected ray here to become the destructive interference. Here we want to what happened here is we want destructive interference. So the optical path we equate it to the m plus half lambda. Okay, so m also the patterns the sequence is from 0, the order is 0, 1, 2, 3, and so on. So for the minimum thickness, we substitute m into here, and we substitute also n and the wavelength 600 nanometer, and we solve for T2, and we get 2.26 times 10 to the power of -7 meter. Okay, so that's the answer for 2B. Okay, next we go to question 3. The surface of a lens is to be coated with a translucent material of refractive index 1.35 so that the light of wavelength 500 nanometer will not be reflected. So calculate the minimum thickness of the coating. Refractive index of glass is given 1.52. Okay, so now we have lens. Okay, so let's say the medium here with refractive index N2 of glass 1.52, so coated with material N1. Okay, N1, no, coated, N2 is the coated material, so N3 is the glass. Okay, so N3 is the glass, N2 is the translucent material, the coated material. The coat, the coat we coat the, what you call this, the glass. Okay, so the N2 will be 1.35, N3 will be 1.52, and N2 will be 1.35, and N1 is the air. So this is how the light travel to the air, and then the coat, this translucent material, refractive index 1.35, so it is reflected. So optical path, the for the first journey of the light will be half lambda, and the second journey, okay, it refract and then reflected, okay, to the medium N2. This is the translucent material of refractive index 1.35. Okay, so the optical path will be 2nt plus half lambda. So why we plus half lambda here? Because N2 is less dense than N3. Okay, so N3 is denser. So if N3 is denser, so that means we need to plus half lambda, not just optical path to NT. And the T is thickness of the coated material. Okay, so now optical path difference between these two will be 2nt plus half lambda minus half lambda, and we simplify this, we get 2nt. So for the destructive interference, how we know destructive interference? Because the question mentioned here, it will not be reflected. So the light of the wavelength 500 nanometer here, we don't want it to be reflected, so we can equate the optical path difference from these two ray, equate it to the m plus half lambda. We get destructive interference here. Here we get destructive interference. So we equate to half plus half lambda, where m order is 0, 1, 2, 3, and so on. So for the minimum thickness, we use m order equals to 0. Okay, then the half lambda minus half lambda is 0. Cancel out half lambda. So we substitute n 1.3 at 5. So be careful not to substitute the refractive index of the glass, because the glass is this one, N3. So it is coated with this translucent material. So we use n of the translucent material, which is 1.35. So we substitute the wavelength given 500 nanometer, and we get the thickness, minimum thickness is 9.3 times 10 to the power of negative 8 meter. So that's the answer for question 3. Okay, so that's the end of the tutorial 14, and see you in the next tutorial.